These are notes on slope. We've been talking about slope as the steepness of a line. It's shown as the change in y, which we call the rise, compared to the change in x, which is the run. So the vertical distance compared to the horizontal distance. To start, we're going to look at the slope of the stairs when walking up the apartment. So we have a triangle shown here. Um, so we're going to start with rise over run. So the vertical distance is 8 feet, and the horizontal distance is 12 feet. So we get the fraction 8/12. We can then simplify that by dividing by 4, and we get the fraction 2/3. So the slope of the stairs would be 2/3. Okay, next example, find the slope of the line. I do want to remind you that if your slope goes up as you go left to right, that's a positive slope. A slope that goes down as you go left to right is a negative slope. Looking at the picture, this one goes down, so we know that our slope is going to end up negative. Okay, so we're going to write rise over run. Okay, the rise this time is actually going 2, so that would be a -2, and the run is 4. So we get the fraction -2/4, which we can then simplify down to -1/2. Okay, our final slope is negative, and that matches the direction of our line. All right, I want you to take a moment and on your own try both of these, and then once you've finished, play it again to check your answers. All right, the first one, if we draw in the triangle, we go down 3 and then right 1. So that would be a slope of -3 over 1 or -3. Okay, number 2, this time we're going up. So this is +2 and then over 4. So that would be a slope of +2/4, which is 1/2. Okay, the first one, the line went down, so it makes sense to have a negative slope. The second one, the line is going up, so it makes sense to have a positive slope. All right, next we're going to graph some lines using a point and a slope. The first thing that you're going to do when you have a problem like this is plot the point. So -3, -4 means you will go left 3 and then down 4. Okay, so we just have the 1 point right here. Okay, now we're going to graph a slope of 3. When you are graphing a slope, you always want to have it as a fraction. So instead of just writing this number as 3, I'm going to write it as 3 over 1. Okay, because then I can set it up rise over run equals 3 over 1. So whole numbers, just put them over 1. Okay, rise is 3. So from my point, I'm going to count up 3. 1, 2, 3, and then over 1 in the positive direction. Okay, do it again. Up 1, 2, 3 over 1. Up 3 over 1. And once you've done that a few times, you will have a line. Okay, all of your points should form a perfectly straight line. If they don't, you might have made a mistake somewhere and you'll want to go back and double check. All right, next one. This time we have a slope of -4/3 through the point 2, 3. So we'll start with our point. Okay, right 2, up 3, and put it up. Okay, our slope is -4/3. Remember, we can write it with the negative in front of the number in the numerator or the denominator. So I'm going to write it in the numerator, and that shows that the rise is -4 and the run is 3. So from my point, -4, I'm going to go down 4, and then +3, right 3. So we're going to count 1, 2, 3, 4, 1, 2, 3, put it up. 1, 2, 3, 4, 1, 2, 3, put it up. Okay, now you start to see the points that form your line. Make sure you always put arrows on the end because that line keeps going even if you're not drawing it. And we have a line through the point 2, 3 that has a slope of -4/3. All right, next up, I want you to write down the first one, a slope of -3/2 that passes through the point -4, -4. So start with our point, 1, 2, 3, 4, 1, 2, 3, 4. And we're going to go down 3, right 2. Put a dot, down 3, right 2. It is also possible to go the opposite direction and go up 3, right 2, so that we can continue that line. Okay, arrows on the end show that it keeps going. Okay, I'm going to show the next several, and I want you to pause it here and try the next 3 on your own. All right, number 2, we're going to start at 1, 3, which is right here, and we're going to go up 1, over 1, because remember this is really 1 over 1. So up 1, right 1, up 1, right 1. Okay, and you're going to get a line that looks like that. Okay, the second one, we're going to write this as -2 over 1. So rise means we're going to go down 2. Run, we're going to go right 1. Let's do that one in green. So starting at 0, -2 right here. Down 2, right 1. Down 2, right 1. Down 2, right 1. And then connect your points. Okay, final one. Rise over run shows that we're going to go up 2, right 5. So starting at 2, -1. Up 2, right 5. And then you could do it again, or you could go back the other direction, down 2, left 5. Okay, so you're going to make sure you get that straight line. Oh, mine went a little off. Let's try that again. Okay, straight line through the points. Try one more time. There we go. So now it hits all 3 of those points. All right, next example. How could you measure the slope of a roof of a house? So what information would you need in order to measure the slope? Because we know that slope is rise over run, we would actually need an extra piece of information here. So I'm going to draw in a right triangle. We actually need the height of the roof and how far out it goes. So I could label that the width or length or something like that. So we need from the top of the roof straight down at a 90-degree angle, and then the distance to the edge of the roof. All right, next we have 2 racetracks, and we need to figure out which slope is steeper by finding the slope of each one. So the first one, rise over run. The vertical change is 21, and the horizontal change is 34. So 21 34ths. The second racetrack, rise over run, would be 26 over 40. So we have the slope of each one. The second one can actually be simplified down. If I divide by 2, I get 13 20ths. Okay, to find the steeper slope, we either need to change them both into decimals or get common denominators or do something so that we can compare these two numbers. A common multiple of 34 and 20, we could use, let's use 680 because they'll both go into 680. So equals something out of 680 equals something out of 680. So we're looking at what do we multiply 34 by to get to 680. We're actually multiplying by 20 because that's how I got that common denominator. So 21 multiplied by 20 would be 420. Okay, so that's multiplying by 20 and multiplying by 20. Okay, second one, this time we're multiplying by 34. And I'll need to work this one out. So 34 times 13, you can work this out with me on your paper. Get 12, 10, 4, 3. So that looks like 442. So we're comparing 420 out of 680 to 442 out of 680. So that tells us that Talladega Superspeedway is the steeper slope because that number is bigger. Okay, so we'll write that in. Okay, and then why are the tracks sloped and not flat? So if you've ever watched cars racing, you will see that the roads are actually sloped as they're going around. And the main reason is it's just easier for the cars to go faster. If the roads weren't sloped, they wouldn't be able to do the high speeds that they do because it'd be easier for them to go off of the road. They wouldn't be able to turn quite as easily. All right, next one, slope of the ski hill. So just like before, rise over run. So that would be 550 feet over 1,600 feet. And then we can start simplifying. That would be 55 over 160 if I divide by 10. And then I could divide by 5 to get 11. And then that one we can work out 160 divided by 5. So that goes in 32 times. So the slope would be 11/32. All right, final one. A construction company is hired to build the roadway shown. The gradient of a hill can be calculated by converting its slope to a percent. So if you've ever been driving in the mountains, like on I-70, you often see signs that say, truckers slow down 7% slope or 7% gradient. It's just a common way to compare the slope. So a 1 to 2% gradient isn't very steep, but 6, 7, 8%, those ones are going to be really, really steep. Okay, percents are always going to be a fraction out of 100. So we're going to find the slope. Rise over run is 70 over 200. Okay, and since we want it as a percent, we're going to convert it so that it's out of 100. So divide by 2, and we get 35 out of 100, which would then be written as 35%. So as far as a road that you drive on the street, that's really, really steep. It says that the gradient of a new roadway cannot exceed 18%. What changes could you make to accommodate this restriction? You have two options. You can either make this distance longer so that that goes out, and then if that's longer, it might go a little bit more like that. So you can see even just making it a little longer can make it less steep. That's one option. Another option would be to decrease the height on your y value. If we decreased it down to that point, you can see how that red line is a little bit less steep. Okay, so two options, and I'll write these up there. Either make the road longer or make the height lower. Okay, and maybe instead of road longer, we'll say the length. That way we're consistent. Okay, two options, either one would make it less steep, and then you'd have to keep going until you got to that 18%.